Hi, this is Warning Coordination Meteorologist Brian Smith from the National Weather Service office in Valley, Nebraska, and welcome to Storm Spotter Training 2019. This training will take about an hour and a half to complete. We'll cover some of the basic storm spotter techniques as well as safety in severe storms. First thing we want to look at is, was this a smart thing to do? This car is traveling towards this tornado and it's moving from left to right. This probably was not a very smart thing to do, driving towards the tornado. Luckily, the person was stopped at the stoplight there. The tornado track just past this intersection while it was moving from left to right. Safety is the most important thing when you're out there as a storm spotter. Here's what's going to be covered in the storm spotter training. Why does the National Weather Service need storm spotters? We're going to cover the severe weather season, severe weather safety, what to report to the National Weather Service, and how to send a report to the National Weather Service. We're going to talk about the supercell structure, which is one type of severe storm that is a prolific producer of severe weather and tornadoes. We're going to talk about other thunderstorm hazards. We're going to talk about wall clouds and tornadoes and what they mean, and we'll talk about how to use radar data. We're going to talk a little bit about fire weather because we're in fire weather season in the spring here for a short time, and then we're going to recap everything at the end. Bottom line, we need spotters to help save lives. The mission of the National Weather Service is to protect life and property. It's also the National Weather Service meteorologist that makes the decision to warn, not a computer. So it's not where the radar sees things and it goes into a computer algorithm and out pops a warning. That doesn't happen. The things we use in issuing a warning are the radar. The radar is invaluable. But we also need to look at the atmospheric conditions that occur where storms are going through. In other words, there are some times where the atmospheric conditions are not conducive to producing tornadoes. Sometimes you will have a supercell that will develop aloft, or what we call elevated storm. And it will be very difficult, if nearly impossible, for that storm to produce a tornado. So the atmospheric conditions are important. And finally, we need ground truth. We need to know what's happening from the cloud base, which is the bottom of the cloud, to the ground. And that's where you as a storm spotter come in. Radar samples the thunderstorm. So here we have the radar sending out a signal, a pulsar signal, to the storm. And then that pulse hits the precipitation and then comes back to the radar. And then we can see how intense the storm is and whatever circulations are taking place in the storm. Unfortunately, due to curvature of the Earth, the radar beam does go higher and higher as you go further and further out. So the radar is covering what's in the yellow area, which is indicated here, and where the spotter sees is in red. This is why we need confirmation of what's happening, because the radar can't see from the bottom of the cloud down to the ground. When is the severe weather season? The severe weather season in eastern Nebraska and southwest Iowa generally starts in either late March or in early April. April, May, and June are our peak months for tornadoes. June is actually the highest month. We get about maybe close to 6 tornadoes in eastern Nebraska and southwest Iowa. This covers a 38 county warning area, which the National Weather Service office in Valley covers. So those 3 months are our peak months for tornado activity, but we can see that tornadoes do occur at other times of the year. Even in the doldrums of summer, where the storm tracks have moved further to the north into the Dakotas and into southern Canada, you can still get tornadoes in July, August, and even September. We may even get a resurgence of activity as the storm tracks and low pressure systems start moving south again in the fall. So even in October, we can get tornadoes. One of the most significant tornadoes to ever occur in October was early October of 2013, which occurred in Wayne, Nebraska, and that was an EF4 tornado. Actually, you can get tornadoes any month of the year if the conditions are favorable. There's even been tornadoes that have occurred in December and January. The time of day that tornadoes occur is generally in the late afternoon, early evening. About 80% of all tornadoes occur between 2 o'clock to 10 o'clock at night. As you can see here, we have a peak that occurs between 4 o'clock and 8 o'clock. This is due to the peak heating of the earth by the sun. This causes the air to warm up near ground level, and with all the moisture in place, the atmosphere becomes unstable. What I mean by unstable is that the air wants to rise upward and form a thunderstorm. The greatest probability of that happening, again, is the late afternoon and early evening. It is very rare for a tornado to occur early in the morning, let's say at 7 a.m. However, if conditions are favorable, tornadoes can occur. In fact, in 2008, we did have a couple tornadoes that occurred in the Millard area of Omaha right around 2:15 a.m. The main thing is to have good situational awareness and be safe. Don't do what this person was doing. Look at this video where the person has a unique way of protecting his vehicle from hail. It's important to be safe out there. Safety is number one as a storm spotter. So we use what's called the ACES system for spotter safety. ACES stands for awareness, communicate, escape routes, and safe zones or shelters. For awareness, it's important, vitally important, in fact, to have good situational awareness of what's going on. Monitoring what's happening with the storms using, let's say, a radar application or weather application would be a good thing to do for a storm spotter. Knowing where your warnings are and where you're located with the storms is vitally important. Once you lose situational awareness, bad things can happen. It's also important to communicate where you're at on a regular basis in a storm watch or when you're out there as storm spotting. So you need to talk to, let's say, a base station to let them know, or dispatch to let them know where you're at and what you're reporting. It's important to have an escape route. Make sure you do not go down a dead end road. Make sure you do not go down a minimum maintenance road. You need to have more than one way to get out in case severe weather approaches you. And finally, it's important to have some sort of safe zone or shelter to go to if you need to bug out when there's a severe weather approaching you or a tornado bearing down on you. Someplace like a home nearby or buildings, some structure like that would be the best thing to do if you're out there storm spotting. There are 5 hazards associated with severe weather. Those are tornadoes, lightning, hail, damaging winds, and flooding from rain. So let's look at the most common hazard that you will encounter as a storm spotter, and that is lightning. So here's a close lightning strike. Very important to be safe out there when lightning occurs. As a storm spotter, you want to choose a location that you will be safe in. You don't want to remain in your vehicle as much as possible during a lot of lightning. You can mitigate the visibility while you're in your vehicle by using something like Rain-X on your windshield so that you can see cloud features better while it's lightning. Here's what we want you to report to the National Weather Service. We want you to use the 4 W's. The 4 W's include who you are, what you saw, where you saw it, and when you saw it. In this case, we have Jane Doe as a trained spotter, and she sees golf ball size hail and 2 large trees that have been uprooted, and these were located 5 miles west of Battle Creek. And when it occurred is that the hail and strong winds began about 5 minutes ago, and it's still ongoing. Now, one thing to add here is if you have a tornado or wall cloud or some other cloud feature, you want to report not only where you're located at, but where that cloud feature is in relation to you. So if you have a tornado that's located 2 miles to the west of you, you want to report where you're at and then report where the tornado is approximately 2 miles to the west of me, and then which direction it was moving, and in this case, we'll say it was moving northeast. Here's some examples of good reports. This is Officer Fife. Baseball-sized hail fell in Wahoo at 8:08. The hail lasted about 5 minutes and broke windows, stripped trees, and damaged cars. This report has the 4 W's in it. And again, these messages, when you send them to the National Weather Service, should be short and concise. Here's another good report. My name is Lucky Jackson. I'm a trained spotter. A tornado moved through my place, which is 3 miles west of Logan, Iowa, on US 30. The tornado hit at about 4:25 p.m. and lasted about 20 seconds. It was moving northeast. A couple of small sheds and a pole barn were damaged, and no one was injured. Again, short, concise, and to the point. This is not the time to call the National Weather Service and give the report and then start asking about what the weather is going to be for the next week or so. How to send reports. There are several ways that you can send reports to the National Weather Service. If you're an amateur radio operator and are operating on a net or have access to one of the amateur radio repeaters, you can send your reports that way if we have amateur radio emergency service operators in the office. And usually on significant severe weather events, we will have amateur radio operators in the office. You can also give us a call using our toll-free number, which is 1-800-452-9074. This number is answered 24 hours a day, 7 days a week, 365 days in a year. It rolls over to one of several phone lines, so if one is busy, it will roll over to another line. So that's another way to send a report. You can submit a report using a web-based form on our website, which is www.weather.gov/Omaha. In the lower left-hand corner of the web page, there is a link to submit a report. And when you do that, you can follow the instructions to submit a storm report, which gets alerted to us at the National Weather Service. You can also use social media to send reports. You can go to us on Twitter at facebook.com/NWS Omaha to send a report, and you can even attach a picture of what you see, and also Twitter, if you send us a tweet at NWS Omaha. Email is probably not the best route to send a report, but maybe you have damaged photos after the fact that you might want to send to us. You can send those to nws.omaha@noaa.gov. But I wouldn't use email for real-time reports because we're not looking at email all the time. And then there's a mobile app out there that you can get that's called MPing. MPing, you can send your location using that app. You can also enter your hail size using that as well. And we monitor MPing in the office too. So let's look at the supercell storm structure. And so we're looking at this storm about 30 to 40 miles away towards the western quadrant of the sky. And there are various cloud features associated with this storm. And so this short video will explain these various cloud features in the supercell thunderstorm. This is a diagram of a supercell thunderstorm viewed from about 40 miles away and looking towards the western quadrant of the sky. On the right, or north and east part of the storm, we have rain and hail, which is associated with the downdraft part of the thunderstorm. On the left, or south and west part of the storm, we have the flanking line in the rain-free cloud base, which is associated with the updraft. And in the middle, where the big tower is is where the main updraft of the storm is. Sandwiched between the rain-free cloud base to the left and the rain to the right is an isolated lowering of the cloud base called the wall cloud. That's where the most intense updraft takes place in the supercell, and that's why tornadoes form under it. Here we're looking to the southwest at a rain-free cloud base of a supercell thunderstorm. And above that rain-free cloud base, you see the building towers of the flanking line. On the right-hand part of the picture is where the main storm tower is, and right underneath that main storm tower is where you would look for the wall cloud and possible tornado. In this picture, we're looking at a supercell storm looking to the southwest, rain to the right, rain-free cloud base to the left, and the wall cloud right in the middle, down basically the end of the highway. We also have an inflow band of clouds on the right that's feeding into the wall cloud. Okay, so that gives you an idea of what you need to look at in a supercell thunderstorm. And the important thing is to be placed in the right position to see these cloud features. So generally in a supercell thunderstorm that's moving southwest to northeast or west to east, you want to be on the right-hand side of the storm and generally on the southern flank of the thunderstorm. And you know you're in the correct position when you're facing the storm and you have warm air blowing in your back towards the storm. So it's blowing in your back towards the storm. You have rain to your right and rain-free cloud base to your left. Then you know that you're positioned correctly. Now another hazard that you're going to encounter in a thunderstorm, a severe thunderstorm, can be large hail. Generally, supercell thunderstorms are ones that have hail golf ball size or larger. Generally, if you start getting hail that big, it is a supercell thunderstorm you're dealing with. Also, hail that gets golf ball size or larger can go through your windshield. And hail that gets to about baseball to softball size has a fall speed of about 90 miles an hour. If you got hit with one of those stones that were baseball or softball size, it could kill you or injure you severely, as it is like getting hit with a major league fastball. So let's look what it's like in driving through a hailstorm. This is actually in eastern Colorado in 2016. There goes my windshield. As you can see, that this storm produced severe hail and at least baseball size that occurred, and really did a number on this car. Here's how to report hail. You want to report the largest hailstone that you see. It's not necessary to carry a ruler with you to measure the hail. You can use a common object to estimate the size of the hailstone. Now, when we issue a severe thunderstorm warning, a severe thunderstorm warning would have hail of 1 inch in diameter or greater. So here we have different sizes: penny, which is 3/4 of an inch, quarter, which is 1 inch. You go up to golf ball size, which is 1 3/4 of an inch, baseball size, 2 3/4 of an inch, and then we have softball size, 4.5 inches in diameter. Try to avoid the term marble hail, because different people interpret what size marbles are. We had a forecaster in our office who answered a call from a storm spotter one time, and the storm spotter reported marble size hail. The forecaster replied, well, was it less than about the size of a penny? And the person on the other line of the telephone said, oh no, it was larger than that. Well, then the forecaster asked, well, was it about the size of a nickel? And the person on the other line said, oh no, it was larger than that. The forecaster then asked, well, was it about the size of a quarter? Well, then the storm spotter said, yeah, it was about the size of a quarter, maybe even a little bit larger. So that person's idea of what a marble size was the size of what's called a shooter marble, which is over here on the left. Also, we want you to report any flooding. This is another hazard you'll encounter with severe storms, and out there is a storm spotter. I want you to report any rates of 2 inches or more an hour of heavy rain. And we want you to report significant flooding, not where just poor drainage takes place. Maybe storm drains are getting clogged, especially early in the season. You get leaves that have clogged up the storm drains or whatever. You want to report flooding over the roadways, cars getting stuck, damage due to flooding that's taken place. Also want to report any road closures that occur due to the flooding. And for you as a storm spotter, you want to be safe. Again, safety is number one out there as a storm spotter. You want to avoid driving through areas of high water. It only takes 18 inches to 2 feet of water to make your vehicle float. And it only takes 6 inches of moving water to sweep you off your feet. This video shows you why you should not go through a flooded area. It's hard to judge how deep the water is. And this person obviously did not think that the water was as deep as he thought. However, you'll see what happens in this video.
God. Oh my God. Dude, you gotta get out of the car. You gotta get out.
What can I do?
Swim.
What?
Swim. Swim.
What to do?
Leave the car. Swim. Stay in the car? Leave the car. Swim. No. Come here, sir. Sir. Come here.
Thank you.
Yes, we're here.
Oh, I didn't see it.
Yes. Hey, we can hear you. Are you okay, sir?
I'm okay.
You okay?
Yeah, I'm okay.
You just watch your step, sir. You got to watch your step. Did you
But
just not think the water was that deep?
Yeah, I didn't.
And as you can see, the person's car started sinking in that underpass. So not a very good idea to do that. The best thing to do is turn around and don't drown. That's kind of a phrase that we have been using with the National Weather Service regarding flash flooding. In fact, last year, 68% of the flood fatalities were people doing just like that person did in the previous video, of driving through an area that was flooded. So that is quite a high percentage of people that have gotten killed due to driving through an area. So be careful when driving in severe storms while you're storm spotting. Okay, now let's look at a cloud feature which you see with a lot of thunderstorms. And this is a cloud feature that's created due to the cold air from the downdraft of the thunderstorm, the air that comes down with the rain and hail, and then that air spreads out near the ground and creates this cloud feature which is called a shelf cloud. So let's look at a shelf cloud. Here's a picture of one right here. I'm circling it right here with my pen. And as you can see, that is a horizontal cloud. It will be pushing out to the cold air and the rain, as you can see in the background. And in this case, it's coming right towards you. So that is the shelf cloud. Now, the one on the left here, this is moving towards the east. So it's moving in this direction. This is the leading edge of the shelf cloud, and right at this leading edge is where you get your gust of wind, or what we call the gust front. So you as a storm spotter want to watch objects in the background like the trees, like over here or over here. You'd want to watch those in case there was damaging winds. You'd watch the trees. If they start breaking or bending, then you'd know that the winds were intense. Now, not every shelf cloud is going to have severe winds with it. You're going to have some shelf clouds that will have a gust front of maybe 40 miles an hour or so. But sometimes you can get very intense winds. This is just the leading edge of that wind called the gust front. So here's on the right, lower right, here's another shelf cloud moving left to right. Here's the leading edge again where the pen is showing, and the air is coming down and out and pushing out. It's rare for tornadoes to form underneath a shelf cloud. There are some cases where we've had, mainly in bow echo storms, that have tornadoes on the leading edge of the storm. But generally, because the air is going down and out and not up, it's rare for tornadoes to occur. Let's look at a time lapse of a shelf cloud. And then this is in Obert, Nebraska. And the reason why it's a time lapse is that you can see the motion of the storm or the cloud a lot better. The shelf cloud is moving gently from right to left in this case. It's actually moving also towards you in this video. And again, the leading edge of that cloud is where you would get your gust of wind or your gust front. If you get wind that gets damaging, you can report that wind to us. It's important to you to report it to us. Now, the winds that occur from the downdraft that do damage are what we call downbursts, which is an intense downdraft that produces damaging wind. Now, many storms that have intense winds in it generally have winds 60 to 80 miles an hour, and this causes trees to either uproot or snap. It causes power poles to go down. It can cause sign damage and some minor roof damage. And the winds can last 5 to 15 minutes. But we can get these high-end downbursts, which have winds 86 to 135 miles an hour. And that creates widespread extreme damage where you can get things like pole barns going down, you can get roofs going off of garages, garage doors buckle, you get some roofing that peels back on the houses, numerous trees get blown down or uprooted. So luckily these events are not as frequent as the other downburst events, but one particular storm that is a notorious producer of the high-end events are what's called a bow echo. And so here's a diagram going from left to right of a bow echo storm. So on the left, we start out with a line of storms, and as we progress east with time, or progress with time, the area in the middle here starts bowing out. And eventually it bows way out, and right here where it's bowing out is where you'd get intense winds. We're going to cover a bow echo a little bit later when we look at radar imagery. Let's look what damaging winds look like from a video perspective. And this is from Sergeant Bluff, Iowa. In 2014, Sergeant Bluff is located just east of Sioux City. And you'll see how intense these winds can get.
Oh my God! Get downstairs, guys!
Very intense winds with that storm. It's kind of interesting that a lot of videographers will be shooting the video while telling the rest of their family to go down to the basement. This person was shooting with the garage door open, so I don't think that was a very smart thing to do. Okay, for wind reports, we want you to report any measured speeds over 50 miles an hour. And some of you storm spotters may have portable wind measuring devices that can give us an idea of how strong the winds are. Otherwise, you can estimate the wind speeds by looking at the trees. We also want you to tell us the size of the broken branches and down trees that have occurred, any structural damage and any impacts like the trees blocking the roads, and whether there's power outages or power lines over the roadway. And don't automatically assume it's a tornado. Just because there's damage doesn't mean it's necessarily a tornado. Wind is wind. The difference is that a downburst is got straight line type winds, while a tornado is a rotary and wind phenomena with also some uplift to it as well. Now, another cloud feature that's very important for you as a storm spotter to inform us about is called a wall cloud. Wall cloud is an isolated lowering of the cloud base that is generally in the rain-free cloud base area of the storm in a supercell thunderstorm. This differs from the shelf cloud, which occurs at the leading edge of the rain and hail. This occurs in the updraft region where the air is going up into the storm. So this large photo here, shown here, is of a supercell thunderstorm, and this is actually near Fremont, Nebraska. And this is the wall cloud right here, where I've circled. This is about 1 to 3 miles wide. Now, you will also see fragments of air and dust maybe going up into the storm. You will see this tail, which is, if you're facing this correctly, is on the right-hand side, and your rain would be to the right. And it's ingesting rain-cooled air and forming this tail. And this tail has sometimes fragmented clouds, which we call scud, that get lifted up into the wall cloud. Also, this whole thing is rotating. It's rotating. The faster the rotation you see with it, the more serious the situation is. Now, this inserted photograph here is also of a wall cloud. Notice the rain-free cloud base surrounding it. And again, this would be rotating. And in this case, we do have a tornado associated with it. So what you want to do is look for persistence and look for rotation. Persistence meaning that this cloud feature stays there for quite some time, maybe 10, 15 minutes or longer. You want to look for rotation in the wall cloud as well. If you don't see persistence, let's say it's a cloud feature that goes down and comes back up and disappears, that's not a real wall cloud. A wall cloud will be there for a long period of time. So let's look at a wall cloud near Louisville, Nebraska. Now, this video was taken in 2018 on June 11, a very active severe weather day in eastern Nebraska. The people narrating the video mistakenly call this a large tornado. What you have to be careful about is that when you see cloud features at a distance, it's hard to tell what's going on with hills and other obstructions in your way, your viewing angle. So you want to make sure that you are careful in assessing what's going on before you come to the conclusion that it is a tornado. And this is not a tornado, by the way. That tornado did occur in Louisville out of this storm, but was a lot smaller. It was not a wide tornado like what was mentioned in this video.
Tornado.
I got it.
There's a tornado on the ground. Here, Linda, hold this for a second.
I got it. I can't.
Okay. Large tornado. I gotta log in. God dang it, a million windows open. We got a tornado on the ground. Okay, guys, we got a large tornado. It's 520.
So you can see how big that wall cloud was with that supercell thunderstorm. It did produce a tornado, but not a very wide tornado like what was mentioned in there. Okay, now let's look at the difference between a funnel cloud and a tornado. They both have to be rotating, usually in a vertical column. Generally, funnel clouds tend to be laminated, so do tornadoes, due to the rotation tightening up. The main difference here is that a tornado is on the ground, where you have debris that is being lifted up into this column, into the tornado. So there has to be rotation and debris visible. A lot of times in the early stages of the tornado, you may have the debris on the ground, and then a funnel will form eventually, and you may not have any connection between the funnel aloft and the debris on the ground. It's still connected though. It's just invisible in this middle part. So that's a lot of times you see in the early stages of tornado development. So let's take a look at a video of a wall cloud and funnel cloud. And this occurred during a time period where you would normally expect severe weather. This is December 1st, 2018. And this is near Beardstown, Illinois, which is in west central Illinois. Here we're looking to the north at this supercell thunderstorm. We're very close to the wall cloud. It's right in front of you here. Notice the rain in the background. It's the rain with the main downdraft areas up to the north. So watch on the right here. You'll see right in here the funnel form. There it is, right there. This eventually did become a tornado, and is very close to developing the tornado right now. Notice the whitish appearance to it too. When you're in the sunlight looking back at the storm, when you have sunlight to your back, a lot of these cloud features like the funnel or the wall cloud will appear whitish in appearance. Or if you're looking into the sun and sun is you're not in the sun itself, the cloud features will appear dark. Okay, now let's look at a developing tornado near Louisville, Nebraska. Now this is out of the same storm where we showed the big wall cloud earlier. This produced a brief tornado in Louisville. It did cross into the Platte River, as you'll see here. You'll see the circulation on the Platte River as this tornado crosses the river. Notice the uplift. Here's the circulation on the river there. No, it doesn't sound like a freight train. That was actually a freight train going through Louisville at the same time the tornado was occurring. Okay, let's look at a mature tornado. Now, tornadoes go through a life cycle. You already saw the early or developing stage of the tornado. Now let's look at a mature tornado, and this is in Havana, Illinois. Again, this is on the same day in December 1st of last year. And again, this is in west central Illinois. When you reach the mature stage, the tornado is the largest and is doing the most destruction. We're going to pan out here so you can see the overall structure of the storm. You'll be able to see the wall cloud and actually the circulation above it, which is what we call the mesocyclone, or which is part of the mesocyclone updraft portion of the storm. Mesocyclone meaning the rotating updraft and downdraft parts of the thunderstorm. So this is the rotating updraft part of the mesocyclone. The final stage of the tornado is generally the tornado turns into a rope or thin filament and will die out, although the tornado is still damaging and still dangerous. I can remember a tornado that occurred in Edmonton, Canada back in the late 1980s, and that tornado roped out but went through a manufactured home park and killed 3 people in that manufactured home park. So tornadoes can still be killers when they become ropes. Now the tornado eventually will die out, but that doesn't mean that another tornado may not occur, because a lot of times supercell thunderstorms will cycle, or what we call are cyclic in nature. So what will happen is that while this tornado ropes out, a new mesocyclone or rotating updraft part of the storm will develop and another tornado will form. So you could have 2 tornadoes on the ground simultaneously, one that's dissipating while the other one is developing. So for you as a storm spotter, is you want to watch your whole sky. You want to watch around where that roped out tornado is, and even look above you as well. So you want to look around in case something else is developing. But here's a video taken in Pfeiffer, Kansas in May of 2012 of a dissipating tornado.
Too late to get me still, Charles. I got a video.
Oh my.
Then it is up
Do
there.
you think it did any damage?
Probably not.
Another kind of tornado that is out there is called a landspout. Landspouts are not as violent or destructive as supercell tornadoes and tend to be much shorter lived. They still can produce damage, and sometimes when they're persistent, we will issue warnings for these events. Because of the high cloud base, it is difficult for a storm spotter to accurately locate where the tornado is. Many times the storm spotter will think that the tornado is a lot closer to them than it really is. Also, it's difficult or nearly impossible to detect these on radar since there's no mesocyclone circulation with the Landspout. So the best way to detect these things is to have frequent spotter reports, and these are used by the National Weather Service for use in statements and warnings of these events. So let's look at what you need to report for funnel clouds and tornadoes. First off, we want to know the location of the feature. Remember the 4 W's, and one of the W's is where you're at. So you want to give us where you're located and then where the cloud feature is, like the funnel cloud and tornado, is in relation to you. And then you want to tell us where the direction of the funnel or tornado is moving. Now, some of these are going to be kind of educated guesses. Don't worry if you're not exactly correct, but it helps us out in the weather office to know what is taking place. And we want to know if there's any damage, and we want to know this information as soon as safely possible. Remember, you're part of the weather warning team, so your reports are important to us in real time, and then we can enact on those reports in warnings and statements. Okay, let's look at this cloud feature, and I'd ask you how you would report this. There's no sound to this. This was taken in York, Nebraska. We have this low-hanging cloud. But the one thing to notice in that video was that there was no rotation and no debris. So what we were looking at in this video was scud, which is a ragged cloud that sometimes hangs down at the leading edge of a shelf cloud where the cold air is coming out and pushing out from the thunderstorm. Or it can be also, scud can also be located near the tail of the wall cloud. You'll see fragmented clouds or scud that gets sucked up into the wall cloud. So scud itself is a harmless phenomena. It's just a lot of rain-cooled air. So if you, again, don't see any rotation, don't see any debris, it's a harmless object. So this leads us into lookalikes. And the lookalikes are various cloud features that may look like tornadoes, but really aren't. So this video, first, we're looking at a pretty clouds, which we call mammatus clouds. These form very high in the thunderstorm under what we call the anvil of the thunderstorm and are harmless. You see a lot of thunderstorms that will have mammatus clouds. Okay, now we are looking at some scud, which is over on the right, and then even some smoke plumes from this power factory off to the left here. And then finally, here's virga. Virga is evaporating rain. Sometimes it takes on a V-like shape or funnel-like shape and will be mistaken sometimes as a funnel cloud. But remember, if you don't see any rotation, you don't see any debris, it's probably a harmless phenomena. If you're unsure of what you're looking at, you can call the National Weather Service office and tell them what you're looking at, and then they can help you in trying to identify what you're seeing. Now we're going to talk about using radar data. Radar data can be very useful for storm spotters in the field or at dispatch centers. There are many good apps out there for mobile devices such as Radar Scope, Pickle 3, and other PC programs such as the Gibson Ridge software, which can be used on a desktop or a laptop. But the radar data should be used for planning purposes for the emergency manager to plan out where he or she is going to deploy spotters. And it's also good for the storm spotters to see where they are in relationship to a storm. However, interpretation should be avoided. Trying to interpret the velocity patterns and the reflectivity data. It takes a lot of training to interpret the radar data. It can be quite complex, so leave that to the trained meteorologist. We're going to look at a couple different radar images here of some significant storms. First is a supercell thunderstorm. This is the radar reflectivity display of that storm, where you have reds and oranges. That is the most intense precipitation in the storm. The yellows and green are lighter precipitation. So let's look at this structure of this supercell thunderstorm. This big area here, which I'm circling, is the main precipitation area to the north and east side of the supercell. This is where your main front flank downdraft will take place, and your gust front from that will push out away from the storm over here and then around on the south side like that. Okay, so that's the main precipitation area. The main updraft area is down to the south. This is where you get the warm air that's being ingested from the southeast and from the south into the supercell thunderstorm. And then that air is spiraling upward in the rotating updraft of the mesocyclone in this area right here. So what happens, this whole thing is rotating, and then precipitation starts wrapping around the back side of the storm and creates a downdraft. And that downdraft comes around and we create a hook. And so this is a hook echo as seen on radar. Okay, so the greatest threat of tornadoes will be in that area of the hook and further east and a little bit south. So that's where the greatest threat for tornado or damaging winds from a very strong downdraft called the rear flank downdraft is on the south side of the storm. To the north, we have the greatest threat for hail. That's up here. That's the greatest threat for large hail. That's where the highest reflectivities are in the storm as this storm continues to move northeast. Here we're looking at a bow echo, and we had talked about bow echoes earlier when it relates to damaging winds. Bow echoes are very fast, and this one is moving very fast, probably 40 or 50 miles an hour to the east. Notice the bow shape of the radar echo. Right where it is bowing out is where you get the greatest threat for damaging winds. Even an isolated tornado can occur near some of the bowed out portions here of the storm. We thought we'd show you a little bit about fire weather, since part of the spring we have a period where we have fire weather problems in eastern Nebraska and southwest Iowa. We do have a website which you can go to on fire weather called www.weather.gov/fire. When you go there, you can click on your county and a map for fire weather forecast details, and you can even submit a spot forecast for things such as a prescribed burn. There are links to Nebraska and Iowa daily fire danger index maps also in this web page. You can also look at hourly weather data too. This is on the lower part of the slide. If you just go to weather.gov and click on the location and then click on the hourly weather forecast, and then you'll get hour by hour weather conditions, which would be temperature, dew point temperature, relative humidity, and winds and wind gusts in 48-hour periods. Here's a recap of what to report. You want to report hail and compare the size to an common object, such as a golf ball or baseball, softball. You also want to report wind speeds over 50 miles an hour. You want to report any wall clouds that are rotating and report tornadoes and funnel clouds and wind or tornado damage, and finally flooding. Don't forget the 4 W's: who, what, where, and when. The one thing to remember is never assume that the National Weather Service knows what's happening at your location. Your report may be the first notification of a significant weather event at the National Weather Service office. And so your reports are important to us. They are ones that will be used in the warning decision-making process. The one thing that forecasters really dislike is when they issue a warning and they don't hear any feedback from that warning. The forecaster needs that feedback. They need to hear what's happening with the storm, because then the forecaster is trying to decide whether to continue the warning or whether to cancel it. Sometimes we issue a warning based on what's on radar, and we're still unsure what's going on at ground level. And then the forecaster is thinking, well, should I continue this? I haven't heard anything. The radar still looks good with this storm that it will continue, or should I cancel it? So we need that information. Your reports are very important to us, the National Weather Service. They're important to your local communities, and your reports do help save lives. I want to thank you for listening to this presentation. For more information on storm spotting, you can go to our website, which is www.weather.gov/OAX. That's O as in ocean, A as in alpha, X as in X-ray, /spotter. And on that page, you will see a listing of other links to things like other online training that you can take, a cloud chart that you can download, and also the Storm Spotter Guide, which is also a PDF file that you can download. Thank you very much for attending this training, and be safe out there this year.